Hello. It's me, John Dalton. You ever look at chemical compounds and think, man, I want to know how they get that name? No? Just me? Well, today's your lucky day. I'm going to teach you what we like to call here ionic compounds. What is an ionic compound, you may ask? What? Wait, what's an ionic compound?
An ionic compound.
An ionic compound is a chemical compound composed of ions held together by electrons. The whole compound is neutral, but it can consist of positively charged ions called cations, not cations. Never pronounce it cations. And negatively charged ions called anions, not anions. It has to be between one metal and one non-metal. Otherwise, it'd be covalent. I'm not dealing with that right now. Now that we know what an ionic compound is, let's get into the reason we made this video. Naming different ionic compounds.
John, what about me? John? John? John?
Ionic compounds. Chop, chop. They're not going to teach themselves.
Okay, John!
You're going to need a periodic table. See this fun little zigzag line here? Anything on the left side, the left side of this table is we're going to count as a metal. Everything on the right side, we're going to count as a non-metal. See these numbers on the top of the table? These are the groups. We're just going to ignore this middle section right here for now, though. These are the transition metals. We're just going to focus on these 1, 2, 3, 4, 5, 6, 7, 8 groups. Note, hydrogen is technically a gas, but it is on the metal side of the table. Just remember that this is a gas. These first 3 groups, 1, 2, 3, are going to be positive due to the octet rule, which is just how atoms want a full outer shell of 8 electrons. However, this last column won't have any charge because it already has an outer shell of 8 electrons. Thank you, he's helping me. This is what the charges will look like. Positive 1, positive 2, positive 3. This one's a little funky. It can be negative 4 or positive 4, depending on what you're working with. Then it goes negative 3, negative 2, and negative 1. And that's 0, as I just explained with the help of my trusty sidekick here. Let's start with something easy. Salt. The chemical compound for salt is NaCl. In actual words, sodium chloride. Be sure to say it right, please, and thank you. If we look at our handy, sorry child, periodic table, no, he's leaving. The charge for sodium, right here, is positive 1. And the charge for chlorine is negative 1. That means when building NaCl, you need 1 sodium and 1 chloride to cancel out the positive 1 and the negative 1 to make 0 so that it is neutralized. Yes. Cations always go first in ionic compound, but it's called sodium chloride. Where did that "ide" ending come from? I thought it was chlorine. It is chlorine. But what you do when you bond the chemicals together is you turn the ending of the name to "ide" instead of the way it used to be. Why? Because it sounds better that way. Now we know that, let's do something a bit more exciting. Let's move to the work table, shall we? Let's bond aluminum and carbonate. But wait, aluminum has a charge of positive 3 and carbonate has a charge of negative 2. How are we supposed to bond them? Well, for this, we like to use a method called the drop-in swap. Now, when using the drop-in swap, what we do is we take the positive 3 charge of the aluminum and the negative 2 charge of the carbonate, and we swap them. What I mean by that is you'll take this 3 and move it down here, and you'll take this 2 and move it down here. So then you'll end up with aluminum 2. Also, don't forget your parentheses or it'll look like there's 33 oxygens and you really don't want that. See, carbonate 3. And there you have it, aluminum carbonate. One more thing. You remember those transition metals? They can be pretty funky. Some of them can have different charges. Tin and lead also have different charges, but they are in different places. A different charge. Who wrote these? Changes how those chemicals act, so they can't possibly have the same name. The way we deal with this as scientists is we just use Roman numerals after the name of the element to show the charge of the element. Because iron 2 is different than iron 3. That's the only difference there. So to sum it up, look at the charges. The positive charge, or the cation, will go first. And the negative charge, the anion, will go last. They have charges that sum up to be neutral. You don't have to do the... But if their charges are different and opposite, you'll need the drop-in swap to fix that. The last step is to add the "ide" at the ends of the elements. And that's that. Enjoy. Make sure to like, comment, and subscribe. This has been some famous YouTuber, I don't know.